Alright, so first semester you saw these problems with i's. This semester you could still see I, or you could see a radical, square root, cube root, fourth root, or whatever. So, even though the bottom does not have an I, it has a square root, and that is still not good. So what we're going to do is we're going to follow the same exact process that we did for the imaginary number. I'm going to focus on the bottom. I'm going to keep square root 3 and keep 5 for both of them. I am going to focus on the fact that the sign in the middle is a negative, so I'm going to change it to a plus sign. Ignore the top. You don't focus on the top when doing these switches. Then you look at it and say, okay, the bottom we're going to FOIL, and the top is not really going to be a FOIL. The top, based on how it looks, is going to be a distribute problem. So typically they're both FOIL, but the way it looks right now, the top is a distribute, the bottom is a FOIL. So let's FOIL the bottom first. Square root 3 times square root 3, based on what we talked about yesterday. We should be pretty decent at recognizing it's now square root 9. That was sort of what we kind of discussed a little bit yesterday. Square root 3 times 5, you can't do an inside number and an outside number. So we're going to keep the 5 outside and keep the 3 inside. Negative 5 and square root 3. Keep the negative 5 outside, keep the 3 inside. And then negative 5 times positive 5 is negative 25. So we FOILed the bottom. Again, we talked about that yesterday, so there's a reason why we did yesterday before today. Then we distribute. So 2 square root 7 times square root 3. The inside numbers are allowed to make a square root 21, and the outside number 2 has to stay a 2. So 7 times 3 is 21, so square root 7 times square root 3 is square root 21. And then when we distribute it onto the other one, 5 is outside, so 2 is outside, making a 10. Plus 10, keep the 7 inside. If we did this properly, I know we did, but here's a way to verify it. If you look at the bottom, does the bottom cancel? Positive 5 square root 3, negative 5 square root 3, those definitely cancel each other out. So that means we probably are doing it okay. Looking at this even more so, let's see if we can factor tree and clean any of this stuff up. So, can the square root of 21 really be factor treed? 3 and 7? Not really. Okay? Yes, it can be factor treed into 3 and 7, but is that helpful? No. Can 7 be factor treed? No. Can the square root 9 be factor treed? Yes. Okay, so that one is a good one. So we're going to go ahead and write 2 square root 21 plus 10 square root 7 over, that's going to become a 3, and then we have this minus 25. Three minus 25 is going to give us, these two right here are going to give us a negative 22. 2 square root 21 plus 10 square root 7. This is not an okay answer. Why is this not an okay answer when this was an okay answer? The reason, you probably are thinking, we have to split it, and if you recognize the split, will one or both of those fractions be reduced or canceled? Absolutely. So on this problem, it was an okay answer because reasonably they're not going to be reduced if you split it apart. Here, this is not an okay answer because if you split it, let's go ahead and split it. We can actually reduce not just one but both of them. So 2 over negative 22 is going to be negative square root 21 over 11. The 1 on top is optional. And then 10 over negative 22. To divide both by 2, we'll get 5 over 11, but it's going to be negative 5 over 11. And so that is the only possible answer because of the reducing fraction idea.